Hi, class. So now we're going to go over how things are oxidized under biological conditions. So in order for so just like we like as chemists, we need to reduce and oxidize things. Nature needs to do the same thing. So nature needs reducing and oxidizing reagents in order to do redox reactions. Um, one such reagent is NADH, which is shown below. So NADH is a reducing agent, and this is the reactive center of NADH. And NADH is a pretty big molecule. There's a lot going on here. Most of it is, um, involved in like making it so that it's recognized by various enzymes and that it is fits in biological systems. But we're going to be focusing on this part of the NADH, which is the reducing agent. So the way NADH works is that um, NADH can deliver a hydride in the form of H minus. When these electrons on the nitrogen kick down, this double bond kicks over, that delivers a hydride towards some kind of carbonyl compound. And then there's a base that is usually attached to some part of an enzyme. And you make an alcohol and you get to NAD plus. So this is going from NADH to NAD plus. Now this is only one way that nature converts carbonyl compounds to alcohols. Now notice that in this molecule here, this is an aromatic molecule. This is not aromatic to aromatic, right? So this is helping this reduction take place. Now, the opposite can happen. So we can use NAD plus as an oxidant. So in this case, what's going to happen is an enzyme with some kind of basic residue is going to remove the proton on an alcohol to make the carbon-oxygen double bond. And then H minus is then going to go and attack this carbon here. This looks a lot like a nucleophilic aromatic substitution reaction, right? So the H minus attacks here, kicks this up to give you NADH. So this process of going from NADH to NAD plus back and forth, that allows redox processes to happen. And so this plays a key role in metabolism in the citric acid cycle. Now, we can't just biologically we can't oxidize tertiary alcohols, and the reason is because when you look at the tertiary alcohol, there's no hydrogen here to eliminate to make the carbon oxygen double bond. You might think the same thing for the phenol, but remember we can oxidize phenols, and it turns out phenols are very easily oxidized compared to primary and secondary alcohols. So remember, if you take a phenol under oxidizing conditions, you make the benzoquinone. And then you can take that benzoquinone, or if you take phenol and you put it under oxidizing conditions, you can make the benzoquinone. That benzoquinone can be reduced back to what we call the hydroquinone, and then it can be oxidized back to the benzoquinone. And the reason why this is important is because this process of going from the benzoquinone to the hydroquinone, so this is a reduction process, so this molecule is gaining electrons, and then we're going from here to oxidation, this molecule is losing electrons. These quinones, they act as kind of an electron transport biologically in the form of what we call ubiquinones. So here, notice that this is an ubiquinone. This is used act to catalyze the conversion of oxygen into water and are found in all cells in nature. So this is helping in the process of going from oxygen into water, cellular respiration, right? So what's happening here is that you have this ubiquinone. This is oxidized, right? So I can reduce this. What's going to happen here is I'm going to reduce this in the presence of NADH. So NADH is going to go from NADH to NAD plus. That's going to be this is going to be oxidized. This is going to be reduced, right? And this acts as the electron transport. Then the electrons that are here now. So this went from being oxidized to reduced. It's gained electrons. This is then going to take those electrons that it gained, right, and then use them to take an oxygen molecule, half an oxygen molecule, not really half an oxygen molecule, but it's going to take that oxygen molecule and make water, right? So this is now reduced. So now this is then going to reduce the oxygen molecule, right? So the ubiquinones act as kind of the electron mediator, like between in this process of going from NADH and oxygen to NAD plus and water for cellular respiration. All right, so that's it. So that's the oxidations of um, alcohols and phenols. Let me know if you have any questions, and I will talk to you later. Thanks.